chain rule. We want to take the derivative of a composite function. The composite function of f of g of x. And so, according to the theorem, we take the derivative of the outer layer, f prime of x, g of x, times the derivative of the inner layer, g prime of x. And if you have f of g of h of x, then you just keep on operating in that fashion to say that this derivative is f prime of g of h of x times g prime of h of x times h prime of x. So it doesn't matter about the layers. You just start from the outer layer, take its derivative, move to the inner. The next inner one, take its derivative, and then the inner layer of that, and all the so-called derivatives are multiples. The power rule is said to be the same thing as the chain rule, but here it's a function raised to a power. So you take the derivative of that, it becomes the derivative of the outer, which is n times the function raised to the n minus 1, then times the derivative of u of x, du over dx, or just u prime. Let's look at some problems. So here, y prime, the power rule, this is 3 times the expression 4x minus 1 to the 3 minus 1 is 2, times the derivative of 4x minus 1, which is just 4. So here, y prime is equal to 12 times 4x minus 1 to the second power. Likewise, for this problem, g prime of x is equal to the 3 times the 4 times 4 minus 9x raised to the 4 minus 1, that's 3, times the derivative of the inside, which is just negative 9. So g prime of x is equal to 12 times negative 9, negative 108, times 4 minus 9x raised to the third power. Here, you write this as 5 minus t to the 1/2 power. So f prime of t is 1/2 times 5 minus t. This is 1/2 raised, well, 1/2 to the minus 1, or 1/2 minus 1, excuse me, is negative 1/2 power times the derivative of 5 minus t, which is just negative 1. And so f prime of t is negative 1 all over 2 times the square root of 5 minus t. Moving further, here y prime is equal to, we better write this so you can see it. This is 6x squared plus 1, and this is raised to the 1/3 power. So this becomes 1/3 times 6x squared plus 1. This is 1/3 minus 1, which is negative 2/3 times the derivative of the inside, which is 12x. And so we say that y prime is the 12x divided by the 3. So 12 divided by 3 is 4. So we have 4x up top, and that's all over this 6x squared plus 1 to the 2/3 power. You can write this as x minus 2 to the negative first power. So y prime is equal to negative times, negative 1. We just say negative times the expression x minus 2 to the negative 1 minus 1 is negative 2 times the derivative of x minus 2, which is just 1. So you can write y prime is equal to negative 1 all over x minus 2 to the second power. Get that out of there. All right. Now you can simplify this and make it easy on yourself. This is t minus 3 to the negative second power, right? So if that's the case, f prime of t is equal to negative 2 times t minus 3 to the negative 2 minus 1, negative 3, times the derivative of t minus 3, which is just 1. And so f prime of t is equal to negative 2 all over t minus 3 to the third power. Again, you can simplify this and write this as 3x plus 5 to the negative 1/2 power. Now it's easy to do that when the numerator is 1 and you can simplify the expression. See, the numerator here is 1, right? The numerator there is 1, so we can rewrite the expression. Makes it easy. If it's not 1, it doesn't matter. If it's a 5 or if it's a 6 here, you say 6 times this expression. And you don't take the derivative of the coefficient anyway. So here, y prime is negative 1/2 times 3x plus 5 to the negative 1/2 minus 1. This is negative 3/2 power times the derivative of the inside. The derivative of 3x plus 5 is just 3. So y prime is 3 all over 2 times 3x plus 5 to the 3/2 power. For this problem, we use a combination of the product rule and the chain rule. So f prime of x is equal to the derivative of the first, which is 2x, times the second, x minus 2 to the fourth, plus the first times the derivative of the second, which is based on the power rule. So this is 4 times x minus 2 to the 4 minus 1, which is 3, times the derivative of x minus 2, which is just 1. And we simplify this. So f prime of x is equal to 2x times x minus 4 to the fourth power plus 4x squared times x minus 2 to the third. I don't know how far they like you to go with the simplification. I just know that when I was in school, why is that a 4 there? It's supposed to be a 2. That wouldn't work out. I'm going to factor out a 2x. That's common here and there. And also a x minus 2 to the third. You have left 1x minus 2 here, plus took out a 2x from here, so it left us with a 2x. So this is 2x, yes, times the expression x minus 2 to the third, times parentheses, x plus 2x is 3x minus 2. We use here a combination of the quotient rule and the chain rule. So this is y prime is equal to the derivative of the numerator, which is 1, times our denominator, which is x squared plus 1, minus the numerator times the derivative of the denominator. You understand that the denominator can be written as x squared plus 1 to the 1/2 power so this is x minus the numerator times the derivative of the denominator. A lot of d's going on. So this is 1/2 times x squared plus 1 to the negative 1/2, that is 1/2 minus 1, times the derivative, this is the chain rule, of x squared plus 1, which is 2x, all over our denominator squared, which just leaves us with just x squared plus 1. And we simplify this. we have the square root of x squared plus 1. See, this is minus the 2 divided by 2 is canceled out. This is x squared over the square root of x squared plus 1. That's all over x squared plus 1. And we continue to simplify that. So y prime is equal to, combine these two terms. Here's a fraction. We're going to add the two fractions. We'll subtract. So we find that the least common denominator, which is the square root of x squared plus 1. So we have the square root of x squared plus 1 all over 1 times the square root of x squared plus 1 divided by the square root of x squared plus 1 minus x squared over the square root of x squared plus 1. And this is all over x squared plus 1. So when you simplify, this becomes x squared plus 1 minus x squared plus 1 minus x squared over the square root of x squared plus 1. We have the same denominators. We can combine the numerators divided by the common denominator, and that was all over x squared plus 1. And so y prime is equal to x squared minus x squared cancels out. This is 1 all over the square root of x squared plus 1 and the x squared plus 1. They both merge together in the denominator. So that's x squared plus 1 times the square root of x squared plus 1, which is x squared plus 1 to the 3/2 power, right? This becomes 1 all over x squared plus 1 times the square root of x squared plus 1. And so this is, the power is 1, and this power is 1/2, same base, so 1 plus 1/2 is 3/2. Okay, so they want us to use the chain rule, so g prime of x is equal to 2 times x plus 5 over x squared over x squared plus 2. This is 2 minus 1, which is the first power, now times the derivative of the inside. The derivative of the inside, you have to use the quotient rule. So that becomes the derivative of the numerator, which is 1 times the denominator, x squared plus 5 minus the numerator, this is x squared plus 2. Not the whole thing. This is the derivative of the numerator times the denominator, x squared plus 2 minus the numerator times the derivative of the denominator divided by the denominator squared. Now we just simplify that. So g prime of x is equal to, yes. So we'll just leave that as it is. And if you want, you can combine this denominator and that denominator, and we'll do it in the next step. This is x plus 5 over x squared plus 2. And up top we have x squared plus 2 minus 2x squared minus 10x. This is all over x squared plus 2 to the second. So now we can simplify further. This is g prime of x, and this is 2 times x plus 5. And we simplify this expression, so we have a 2 there. Make sure that's correct. This is a 2, and then this is minus 10x, and then x squared minus 2x squared is just minus x squared, and this is all over x squared plus 2 to the third. I think that's good. Well, there's 2 or 3 more problems. We have this function. We find f prime of theta. So this becomes, think about it, this is 2 times tan of 5 theta times the derivative of the tangent 5 theta, which is the derivative of tangent is secant square 5 theta, times the derivative of 5 theta, which is 5. So f prime of theta is 2 times 5 is 10 times tangent 5 theta times secant square 5 theta. So that's the chain rule. What about this one? Y prime is the derivative of the outer function is the sine. So the derivative of sine is cosine of the tangent 2x. Now take the derivative of tangent 2x. That's secant squared 2x. Now take the derivative of 2x. That's 2. So you can write y prime here as 2 times this cosine of tangent 2x and then times secant squared 2x. Then the last one. So y prime is equal to the derivative of, it's the derivative of the cosine times the derivative of the square root times the derivative of sine times the derivative of tangent times the derivative of pi x. So this becomes negative sine of the square root of sine of tangent pi x times the derivative of the square root, which is 1/2, times sine of the tangent pi x. Close that up, close that up. This is raised to the, this is 1/2 minus 1 raised to the negative 1/2 power, times the derivative of the sine, which is cosine of tangent pi x, times the derivative of the tangent, which is secant pi x, times the derivative of pi x, which is just pi. So we can write our answer as y prime is equal to, let's see, that's times, that's a negative, so it's a negative pi, and this is sine of the square root of sine of tangent pi x. This term with the negative exponent will go downstairs, so we have the 2 will go downstairs, so this is cosine of tangent pi x times secant pi x. And this is all over 2 square root of sine of the tangent pi x. Can we cancel this sine of the square root of sine of the square root of sine tangent pi x, or can I cancel this square root out with this square root? No. because this is the sign operating on this radical. This is just a radical, so they're totally different. This is a sine value, right? This is the square root of something else. So this is the answer. Thank you.